Hello students, welcome to this model number 5, that is ideal gas. In this chapter we are going to discuss about the numericals. So let us we have a discussion on this numerical 1. Okay, this is a problem like this. A mixture of methane with just enough oxygen to permit combustion is burned. The temperature and the pressure of the final mixture are 27 degrees centigrade and 101.3 kilopascal respectively. And calculate, first one is mass fraction of the reactants and the volume fraction of the products and the partial pressure of the water vapor in the products of the combustion and the volume of the products. So these are all the things we are going to find out from this chapter. Okay, so let us will begin with the solution, how we are going to solve. And first, whatever the problem they may give, these are the some steps we have to follow. Okay, given data we have to write. Okay, so we must have an idea when it is methane is burned with the pure oxygen, so it releases carbon dioxide and water. Okay, this is the reaction, chemical reaction. So which one we call it as reactants and which one we call it as products? So whatever the reactants are there with the chemicals here before combustion, so that we call it as reactants. Once if we done some exothermic or endothermic reaction, then whatever the things are getting, that is we call it as products. Let us we have a look. First reactants. First we have to calculate what is the mass of the reactants. Okay, so mass of the methane, that is MCH4 is equal to NCH4 into MCH4, means what is the quantity of the uh, methane and along with the molecular weight. Okay, so that is a mole. It is given, it is 1 into T is 16, C is 12 and H is 4. 12 plus 4 is 16. So this is a 16 kg of mass of methane will be there. And similarly, if you want to calculate the mass of the another constant, there is oxygen. Oxygen is 2O2, that is 2 into 16 into 2, that is 32. 32 into 2, that is 64 kg, that is also oxygen. So these are all mass of the reactants. Now we will come to this calculating the mass fraction. So what is the formula of mass fraction? Mass of the individual constant to its mass of the total mixture. So total mixture constant is how much? That is 16 plus 64. Okay, that is around 80. Okay, 64 plus 16 means around 80. So 16 by 80 is 0.2, and MfO2, that is mass fraction of the oxygen, that is 64 divided by the 80, that is again it becomes 0.8. So this is the mass fraction of that particular gas. So now let us look at what are the products once if it is done, combustion is taking place, that we have look here. Okay, then the products are the volumetric fraction. The volume fraction is equal to mole fraction, as already you know that. So volume fraction of CO2, that is 1 divided by 3. So because why we got 3? Because we have considered for the CO2, that is 1 plus 2, that is 3, that is 1 by 3 is 0.33. And similarly for the volume fraction for the H2O, again 2 by 3, that is 0.66. So here we can find out the partial pressure of the reaction is equal to mole fraction. So then PH2O divided by P is equal to XH2O. That is we have to calculate what will be the pressure. So to calculate pressure, partial pressure, we have to use this formula, and we are getting 0.666. Okay, so once we got this value, again we have to use this partial pressure equation, that is PH2O is equal to 101.3 into 0.666. Then how much we got? Around 67.266 kilopascal. So total number of moles of the products are equals to N is equals to 1 plus 2 plus 3. So N is equal to 1 plus 2 is equal to 3. Then apply a general gas equation. We know that PV is equal to N bar RT. So we know that pressure we know that n number of moles, we know that r bar, and we know that t. So in the problem, while converting this equation, that is v is equals to n r bar t divided by p. Okay, n is 3 and r bar is that is universal gas constant. We are getting 8.314 into 300. So that is divided by 101.3 is equals to 73.86 meter cube. So this is the volume of that gas. So 73.86 is the volume of the gas. So this is how we are going to calculate. So as per the problem, they asked to find out reactants mass, quantity of the mass and mass fraction, and what are the products of the volume fraction as well as volume. So this is what the question they asked. So this is the solution for that. So majorly what we have to understood in this problem is whether this methane, whatever the particular gas which is given, whether it is completely burned of the particular gas, that is oxygen A, along with the hydrocarbon fuel, that is CH4. So we must understand what are the products it releases once it is burned with the oxygen. So if you know this concept, then you can easily balance and find out the required answers. That is CH4 plus 2O2, then it releases carbon dioxide plus water vapors. So this is the chemical reactions. So once if you know these reactions, accordingly you have to solve this problem, whichever the aspect they asked. Okay, I hope you understood this problem properly. So the step by step you have to solve this problem, and the thing is that the units are very must after solving the problems, because here you are mentioning that pressure. Okay, you know everything of values which are going to substitute in the equations, but after finding the values you are not able to put proper units, so no meaning. So please take care while writing the answers along with the units. Okay, so I hope you understood this problem, and we will move on to the next problem for this particular ideal gas problems. So one thing you remember that from this for the chapter ideal gas, so basically you must know this basic equation of ideal gas, that is PV is equals to RT. Okay, PV is equal to RT. So if you know this basic equation along with this whatever the number of moles they ask, they have to substitute and do the calculations. So any one of the parameter they not asked, then we must able to find out those values and substitute in the equations, and then you will get the desired answers. Okay, so I hope you understood this problem, and then we will move on to the next numerical for this chapter. Thank you.